All right. We are in section 13.8 where we are going to interpret box and whisker plots. So if you look on the top, it says box and whisker plots organize data values into four groups. Ordered data are put into 5 number summary based on the number of terms there in each data set. So one of the things that uh, we're going to do is we're going to have to find those 5 number summary values. And those numbers are the least value, the lower quartile, the median, the upper quartile, and then finally the greatest value. So, um, and that is where those terms are going to be in the box and whisker plot. So right here is going to be located for the least value. The value that's going to go here is our lower quartile. This line here will represent the median. The end of the box is going to represent the upper quartile. And this final point at the end is going to be our greatest value. Okay, so right here it says steps for creating a box and whisker plot. So the first thing you got to do is order the data. So order the data from least to greatest. And then you're going to find the 5 number summary plot. Okay, now being able to discover what those 5 numbers are, um, we have to be able to figure out one of two things. One is the set of data that we have an odd number of data, or is the set of data an even number of data? It changes how we find those certain values depending on if the number of data sets are even or odd. All right, I'm going to show you both ways. Next, we get to draw the box from the lower quartile to the upper quartile, and then finally we draw a line from the box to the least value and the greatest value, and then we put that line somewhere in the box to represent the median. Okay, so let's look at an example. So here it says that the prices in dollars of a 27-inch television at an electronics store are given below. It says make a box and whisker plot of the television prices. So if we look at steps on being able to solve this, we need to order this from least to greatest. So looking here, the smallest value is 188, so I write that down. So I'm just going to like X them out as I find them. The next largest is 192. Cross that out. The next one is 224. And then we got 225. Cross it out. The next one is 239. Then from there we have, looks like 271. And then we got 275. We have 286. And then we got 316. And then to finish up, we have 334. Okay. So we got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. All right. So we got all the pieces of data and they're ordered now. from least to greatest. So the first thing that you are going to do is you are going to try to find the least and greatest value. So I'm going to place a circle over my least value, my greatest value. So that gets represented. And so I'm just going to make a line here. I'll make my box like so. I'll go here. And then I got 334 and I got 188. So that represents my least value, my greatest value. Okay. Now what we get to do is we have to find the median. So I look here and I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So I have an even number of values. So my median comes from, so I got 1, 2, 3, 4, 5. So it comes from this value and this value. So when you have an even number set of data to find the median, in this case, it's not the number itself. You have to take 239, add it to 271, and then divide that by 2. So when you get that, you get a median of 255. So find where 255 is kind of, and then I'm going to write in 255. Okay. So now that that is not used, so now you have three terms here and three terms here. So now those three terms are going to help you find the lower and upper quartiles. Okay. So it's kind of like finding the median of the lower half, and it's kind of like finding the median of the upper half, and you kind of omit or don't use the data from least value, greatest value, and median. So between these three values, the middle value is 224. So it's right here. And this value here is 286. So that is how we would find um, the uh, the box and whisker plots for that. So I got 188 as my least value. I got 224 as my lower quartile. I got 255 as my median. I got 286 as my upper quartile, and I have 334 as my um, greatest value. So, but let's say, just for instance, let's say you had an odd number of values. So let's just what if I just add a page? So let's just say if I use the same values here, like the 188, 192, 224, 225, 239, 271, uh, 286, 316, and 334. But let's say I added one. Let's say on the lower end, let's say I had 175. Okay, so now I have 11. So I got 1, 2, 3, 4, 5, 6, 7, 8, 9. Hold on. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. What did I miss? So I got 188, 192, 224, 225, 239, 271. Oh, I missed 275. So sorry about that. So 275, 286, 316, and then 334. Sorry about that. So now I got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So least value is 175. Greatest value is still 334. Okay. So now when you look here, so greatest, least value, and greatest value. So now I look at the middle value. So that's 1, 2, 3, 4, 5, what, 6? Because I got 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. So the middle value is right here. All right, and it's a singular number. So this is, I don't have to do any, find the middle piece because we already have a middle value, so I don't have to add up two pieces and divide it by two. We found the median, which is 239. All right, now this, to find the upper and lower quartiles, this is where you have even number of sets of data. So I have 4 in our lower half, I have 4 in the upper half. So now, in order to find my upper and lower quartiles, I have to add up those two numbers that I wrote as rectangles and divide those by 2. So then if I took 192, add it to 224, and then that gives me 416 divided by 2, I get 208. So 208 is my lower quartile in this particular example. And then my upper quartile is going to be 275 plus 286. Divide that by 2. So now I got, what, 280.5. Okay. And so that's where it changes a bit, where you do use your finding your average, whether if it's an odd number of sets of data, you're going to try to find the average for your upper and lower quartiles. If it's an even number, you are going to use um, the averages for the median. Okay, so let's look back at our previous page, and what we have here is we are now given an uh, box and whisker plot below, and it talks about, it says, shows the normal monthly wind speed in miles per hour, and it says in the cities of Athens and Savannah, Georgia. So it looks like the top right here, this is Athens, and then the bottom right here is Savannah, and so it gives us certain values of data. Okay, so what we have to ask ourselves here, it says, for how many months is Athens wind speed more than 8.3 miles per hour? Okay, so here is how we go about solving that. So, excuse me, we have 12 months in the year. I got, I got like January, February, March, April, May, June, July, August, September, October, November, December. So I got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So I got 12. All right. So what I'm gonna do is actually let's just let's just erase the dates, because let's just put 12 slots. So I got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So I got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, great. So what I'm going to do, it talks about Athens. So we're looking at Athens. I have my least value, my greatest value. So I know that 5.8 is going to go here, and I know that 8.7 is going to go there. Okay. Now, since it's an even number, so I got 1, 2, 3, 4, 5, 6, and 1, 2, 3, 4, 5, 6. My median is going to come from these two numbers. Okay. I don't know exactly what those two numbers are, but I do know that when you average them out, you get 7.2. So since I really don't know what it is, all I'm going to say is I'm going to put 7.2, and I'm going to put less than 7.2. and then I'm going to put 7.2 over here, and whatever it's going to be greater than. All right, I don't know what it is, but I just know it's going to be greater than 7.2. Okay. Uh, from here, now I have 1, 2, 3, 4. 1, 2, 3, 4. So looking at this now, these are my least value and greatest value. So now I have, looks like another, to find my upper and lower quartile. So it looks like lower quartile is 6.5. So I got 6.5 here and 6.5 here. I just know it's going to be less than here, and this is going to be greater than. And over here, this is going to be 8.3. This is less than 8.3, and this is greater than. All right. So this is kind of, and these values here, I don't know what they are, so I'll just put X's over them. So the question was, is how many months is the Athens wind speed is more than 8.3 miles per hour? Well, anything that's, so this 8.7 will be this, whatever this miles per hour average would be. And then I know that 8.3, this is going to be greater than, so that gets a star there. This 8.3 is less than. So for 3 months, we have Athens wind speed is greater than 8.3 miles per hour. Okay. So if you look at the next question, it says compare the wind speeds in the two cities. So if you were to look at the wind speeds between the two cities, just by looking at this, it seems like uh, the wind speed seems to be stronger in Savannah than it does in Athens. Um, but wind speeds seem to be more varied in Athens, so that's what would be my comparison. Final thing, final thing we have to look at is talks about outliers. All right. Now, some sets of data may have outliers and some may not. So here's how we determine if any piece of data that's given in a data set is considered to be an outlier. It says data values greater than the upper quartile by 1.5% times. It says IQR. IQR is interquartile range. I'll explain what that is. And then it says data values less than lower quartile by 1.5 times the interquartile range. So interquartile range is essentially you are taking it's kind of like a range where but you're taking the upper quartile and subtracting it by, so upper quartile subtracted by the lower quartile. So let's take a look at this example here with the televisions. So we have an upper quartile here of 286. We have a lower quartile of 224. So to find the IQR, the inner quartile range, you guys are going to take the upper quartile, which is 286, and subtract it by 224, which then that equals, so 286 minus 224 is 62. So 62 is your interquartile range. All right, so you asking why is that relevant? All right, so now what it says here is you were trying to find data values greater than 1.5 times the interquartile range. So you're going to take the interquartile range here, 62, and you're going to multiply that by 1.5, which then equals 93. So we're going to see if you have any outliers. Is what you're going to do now is look at what it says. It says data values greater than the upper quartile by 1.5. So what you're going to do is to find the outliers for the larger values, you're going to take your upper quartile, which is 286, and you're going to add it to this 93. So 286 plus 93 is equal to 379. You're going to look at your lower quartile, which is 224, and then that gets subtracted by this value here, which is 93, which then equals 131. So to figure out what the outliers are for this particular example is if you had any value that was larger than 379, that would be considered an outlier. If you had any value smaller than 331, that would also be considered an outlier. So if you look at the data here, there is no value that's smaller than 331, and there's no value that's larger than 379. So in this particular instance, we have no outliers. Okay? And that is how we interpret box and whisker plots. Hope this helps. Till next time.